So in this video we're going to apply LHpitals Rule for an example that has the indeterminate form 0 over 0. So the first thing, here's LHpitals Rule sitting up here. The first thing that you have to do is verify that you have an indeterminate form. You cannot use LHpitals Rule if the form isn't an indeterminate form. So you start by looking at this and saying, hey, does this have an indeterminate form? And so in this case, if I think about the sine of 0, you know that the sine of 0 degrees or radians is 0, and clearly the limit as x goes to 0 of x is going to be equal to 0. So clearly the form is an indeterminate form. So in the homework, usually the expectation would be that you identify the form. You say, hey, the form is 0 over 0. But what you should never have is this. Something where you just plug in the stuff. So this gets you marked down on an exam for a variety of reasons. But the first one is you can't do this. We can't divide by 0. We cannot divide by 0. So plugging 0 in here where I have a division by 0 is garbage. So we can't do that. But we can tell the reader what form we have. So here I'm saying, hey, the form is 0 over 0. I'm not trying to take the ratio 0 over 0. I'm just identifying the form. And because I see that the form is 0 over 0, I know that I can apply LHpitals Rule. So I'm going to rewrite my limit. I have the limit as x goes to 0 of sine x over x. And this is going to equal, I recognize I have an indeterminate form, and I should remember this. This is a limit I should actually remember from Calc 1. This limit's going to be equal to 1. This was an important limit in Calc 1 that we needed to use to come up with a lot of the rules and techniques that were developed in that course. But we want to recognize that because we have an indeterminate form, we can use LHpitals Rule. LHpitals Rule says, hey, it will be sufficient to look at the derivatives of f and g, their ratio. So we take the limit as x goes to 0. LHpitals Rule guarantees that if we take the derivative of the sine, which is the cosine, and the derivative of x, which is 1, that this limit will be the same as this limit here. And then this equals, what I want to recognize is that I can actually plug the 0 into the cosine function because cosine of 0 is 1. So I'm going to go ahead and say, hey, this is a form that doesn't cause division by 0 or anything bad to happen if I plug the limiting value in, so it's okay to plug in the 0. So cosine divided by 1 is going to be cosine. Cosine of 0 is 1. So by LHpitals Rule, the limit as x goes to 0 of sine x over x is equal to 1.